Hello, and welcome to a little lesson about vertical and horizontal asymptotes in rational functions. So, the first thing we need to look at is what in the heck are asymptotes? So, asymptotes are lines that a curve will approach when it heads towards positive or negative infinity. These asymptotes are causing this L shape to form with our equation for the most basic rational function, g of x equals 1 over x. Now you may remember from previous sections, we called the most basic functions, we called them parent functions. So this is its parent function. Sweet. Let's draw in these invisible asymptotes. So when you're graphing, usually on like a calculator or any other graphing device, you won't see the asymptote. We're going to have to use our imagination. Now, the line really isn't there, so we need to draw a dotted line. A dotted line, in mathematical terms, represents a line that doesn't really exist there. Like, the line is there, but not really. It's kind of like us using our mathematical imaginations. So I'm using technology to help me draw a straight line, and then I'm drawing in some dashes with my white marker. Okay. This asymptote is known as, whoops, well that y didn't work. Let's try that again. As y equals 0. All right. So again, we don't see it, but it is there. It's just invisible. We have one other asymptote for our original function. Here it is. This one is x equals 0. Now, asymptotes are lines that we get so close to. We get so close to, but we're never going to touch. It's a very sad love story for our equations in which they get so close, but they never touch. So sad. I know. So sad. Again, this one is called x equals 0. All right. Ooh, that's ugly. That's an ugly 0. I'm going to try that 0 again. Let's try it one more time. Boom. All right. So, asymptotes come in several shapes and sizes. Well, their size is infinite since they have arrows on both sides. But we have horizontal asymptotes. These will always be y equals some number. We will also have vertical asymptotes. They're always x equals some number. In some cases, we may even have oblique asymptotes. Oblique asymptotes are asymptotes that aren't vertical or horizontal lines. Sometimes they are diagonal lines, like y equals mx plus b. There have been times, and these are crazy times, where I've seen some quadratic oblique asymptotes. Those were super crazy. We're going to focus on vertical and horizontal. So let's look at some graphs and at their horizontal and vertical asymptotes. Okay, so here is graph number 1. This is its function. Let's find the asymptotes. And again, I'm just going to use the picture of the graph to find my asymptote. It looks like I have a nice horizontal asymptote right here. Let's draw in the dashes with the white. I guess I don't really need that many dashes, as long as it's dashed. All right. The equation to this one is y equals negative 4. All right, let's find our vertical asymptote. I know I over-enunciate the P, but that helps me get the spelling right each time. So asymptote it is. Let's draw in some dashes. And again, I'm just using my eyes, my imagination, to see where this is happening. Okay, and that is at x equals 0. Let's write that down, x equals 0. Yes, I'm over-labeling, but I like it. Let's try the next one out. Aha! All right, let's switch on my imagination. I'm looking at f of x equals 1 over x plus 3. Let's draw my horizontal line. It looks like it's right there. Yes, beautiful, it is. I know it is because it looks like the curve is getting super close to it, but never crossing it. Yes, there are super crazy times where we cross it. Yeah, it does happen. We're not going to talk about that right now. This asymptote is y equals 0. Next, let's do our vertical one. Okay, where do I think it goes? I'm going to select my orange marker. And it looks about here-ish. Yeah, that looks good. Let's get my white marker. I'm going to dash, dash, dash. Dash, dash. Whoa. I don't know how that happened, but the dashes have appeared. Okay, wondrous. Wondrous. This line is x equals -3. How did I know it was -3? It crosses -3 right there. Okay, let's look at one more, and then I'm going to point out a pattern, and hopefully you already see it. But if you don't, hopefully you'll see it now. Or after, then. Cat's got my tongue. This is the graph that we're looking at, this h of x. Let's draw in our horizontal asymptote. I'm going to select my blue marker. Boom, 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 boom. Okay, and let's select my white marker. Just going to give it some dashes. So dashing. Oh, yes. So dashing. Dashing. Okay, what does this look like? This looks like y equals 2. And of course, with my over-labeling, still gonna write it here. Y equals 2. Okay, next we have our vertical asymptote. Looks like it's right here. Yes? Yes, okay. Let's zoom in. Let's draw my dashes. Oops, 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 oops. Sorry. Let's draw in our dashes. I meant to move the line. I wanted to make it a little bit more perfect, but that's fine. Ooh, this is a nice one. We see exactly where it's going through. It's going through 5. Okay. This asymptote is x equals 5. You're probably thinking, Miss Gumin, I don't want to do this every single time. You have to graph each one. You have to look and imagine the asymptotes. Not quite fun. Can you make this easier for me? Why, yes, I can, dear student. Check this out. Our horizontal asymptote in this problem is y equals 2. Do you see another 2 in this problem? I do. Here it is. Well, should it be there in every problem? Let's check. Up I go to this one. Horizontal asymptote, y equals 0. There's nothing here. Oh, my friend. Nothing is 0. Success. Okay, how about this one? Horizontal asymptote, y equals -4. Check that out. Boom. Can I do the same thing with x's? Can I do the same thing with my vertical asymptote? Yes. Why, yes, we can. Check this out. I know I have a vertical asymptote here of x equals 0. But you know what? On the bottom, I have x by itself, and I could write it as x minus or plus 0. So it still is coming from down there. Let's check this one out then. Aha! Horizontal asymptote, vertical asymptote is -3. Does that also come from the bottom? Yes. Notice, please, This is x plus 3. Our asymptote is a -3. Let's see if the same thing happens in the last one. Vertical asymptote, here is x equals 5. On the bottom, I have x minus 5, asymptote positive 5. So our vertical asymptotes will be the opposites of what you see on the bottom, but our horizontal will be the same as outside. I hope this helped you understand horizontal and vertical asymptotes a little more. Next, I'll be doing domain range and end behavior, but that's for another video. Let me know or your teachers know if you have any other questions on this. Otherwise, have a wonderful rest of your day. Bye.